All right, chemistry. We are picking up where we left off, which is actually a brand new topic, right? We left off on quiz day. Um, Quiz grades went up. They were one of the last grades for first marking period. What we're starting here is like the first thing I'm going to do for second marking period. There is going to be a test in your relatively near future. I would imagine within the next 2 weeks. I'll keep kind of looking at how we're progressing through this and figuring out when that exactly is going to be. But we've talked about like numbers and calculations. We've talked about atoms and their structure, protons, neutrons, electrons, ions, and isotopes. Now we're going to get into taking atoms and putting them together, so forming molecules, forming compounds, making the formulas for those things, and naming those things, right? So we're like right on the cusp of actual chemistry. Soon we'll be able to do reactions, but we can't do reactions until you know what the compounds are made of, how they're put together, and what we call them. All right. So, right here, this is page 19 of your notes, page 20 right here. So we're gonna pick up talking about molecules, compounds, formulas, and naming. Right. Brand new stuff. So, first bullet point under molecules is, like it usually is, a definition. What we have here is that molecules are the smallest identifiable sample of a substance. It's the smallest thing that you can consider to actually still be that substance. If you get any smaller, then you're getting into atoms. So a molecule is typically the identifiable sample. Words. Identifiable sample of a substance. So, again, molecules specifically are where two or more atoms are linked together. If you have exactly two atoms, you have what we call a diatomic molecule, and I will usually refer to them in this order: Br, I, N, Cl, H, O, and F. I will call them Brinkelhoff, specifically the Brinkelhoff buddy system, right? And the reason that I do that is because each of them is always two, right? If you see these elements floating around in nature, they always float around as what we call diatomic molecules. Di, like two, atomic, like atoms, so two atoms put together, floating around. They always use the buddy system. You'll never find any of these elements floating around on their own. They'll either be combined with themselves, right? So H will run around with another H, or H will run around with another element entirely, but they always buddy up with something. Now, I bring that up because, again, it's occasionally a very specific question. Which of the following elements forms a diatomic molecule? You will have to look for one of these seven. Brinkelhoff. Brinkelhoff buddy system. Try to remember it. This is actually one of the few times I will ask you to remember something, so please try to remember it. Most of the stuff is in your reference table. Brinkelhoff buddy system is not on your reference table, right? It's my little thing for molecules. We'll move on to compounds a little lower. Again, first part is a definition. Oh, and just kidding, I'm still on the highlighter. Alright. A compound is a substance that is formed by the chemical combination of two or more elements in a definite or fixed ratio. Same definition we had as before. A small clarification. All compounds are molecules, but not all molecules are compounds. Alright, something like H2O is a compound. It's also a molecule. Something like O2, again, part of our Brinkelhoff buddy system, is a molecule, but it's not a compound because it's only one element. Which is why we say that, generally speaking, if you have at least two capital letters, then that molecule that you have is a compound. If there are exactly two capital letters, and you have exactly two different elements because you have exactly two different capital letters, then that compound is special, we call it a binary compound. Again, binary. Binary like 2, right? A binary system of numbers has only 2 numbers. Binary compound has only 2 elements. If you have more than 2 capital letters, it usually indicates that there is a polyatomic ion present in the compound. Hopefully you remember polyatomic ions. They're on your reference table. Table E, page 2. Special names, special charges. All right. Now, very important point. Right. Really, this whole bullet point, very important point. All compounds are electrically neutral, which means that they have no charge. All right. All the positives, all the negatives, they add up to 0. It's going to be really important when we start actually making compounds and when we start naming compounds, because it's going to tell us how many of each thing or how much of each thing is present in there. All right. Now, quick, dirty exercise. Really just quick, right? Identify 6 things down here. Is it an element? Is it a compound? I'm going to ask you to pause the video. Try these in your notes. I'll do the answers in a moment. You should be pausing the video, trying those questions down there. Not these ones right below. Those ones over in that direct. I can't. They're down there. Here we go. I'm just going to do E for element, C for compound. I'll answer that part first, and then I'll say, does it have poly? Can't, no, no, yes, no, and yes. This poly, if I checked table E, would be a nitrate. This poly, if I checked table E, would be sulfate. All right, more than 1 capital letter compound, more than 2 capital letters, probably has a poly. We'll get into how to tell or not. Actually, very soon, like maybe tomorrow. Well, tomorrow, the next day, right? All right, just a little more. I want to talk very quickly about the basics for a chemical formula. Chemical formulas are things like H2O, like CO2, C6, H12O6, right? These things that tell us something specifically. They tell us about the composition of the element or the compound, right? Technically, the chemical formula for an atom of an element is just the symbol. So Ca is the chemical formula for calcium. When you see chemical formulas, something like H2O, then this number down there is called subscript. Sub, like below, script, where you would write. So remember, if this is a script, superscript happens up here, subscript happens down here. So the subscript tells you how many of an atom or an element are in that compound or molecule, and it always belongs to whatever it comes after. So that 2, this 2 here, belongs only to the H. If you do not see a number, if you do not see a subscript, what is implied is a number 1. So if I did something like this, it implies that there's 1 carbon. It tells me exactly there are 2 oxygens. Be careful with parentheses, right? Something like this. When you see parentheses in math class, your thought should be like distribute, right? Multiply it through. You'll do the same thing here. You will multiply that subscript by the other subscripts that you see. So here in BeOH2, there's 1 Be. There are 2 oxygens and 2 hydrogens. Right? If you saw something like MgNO3 parentheses 2, this is 1 magnesium. This is 2 nitrogen, because this 2 distributes, and then you distribute. It's 6 oxygens, right? Distribute the 2 times 1, distribute the 2 times 3. That's how I get to these numbers. If I haven't said it yet, counting is hard, and here is why, okay? Please don't discount your ability to count. Now, what I would like you to do for next time is these 8 really 7 examples because this one is done for you. I'd like you to name the elements in the compound and count how many of each element is in that compound. This might seem trivial. This might seem like a very small thing, but please, 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 it's going to be really important when we get into doing actual chemical reactions that you know how to count and you know how to be able to tell how much of each element, how much of each polyatomic ion, how much of each compound is on one, is in something, is in a molecule, all right? So these 7 questions are here on page 20 are your homework. The assignment should go up onto my CBA. Brand new topic is where these notes are found. As we finish them, I will do my best to make sure that they're in there. I will probably put a delay on them so that you guys actually have to do the work. You can't just copy the answers down. Sorry, kids. In any case, that's all for today. That was A day, right? B day coming soon. We'll continue on page 21, which is not here, but it will be soon, right? I'll keep filling in our little timeline here. If you have questions, let me know. Otherwise, I will see you on B day. Take care, kids.